Okay, we're starting with Chapter 1, Ingredients of Change, Functions and Limits. So Section 1.1 is on functions, the four representations. So calculus overall is the study of change, how things change as well as how quickly they change. And there are four representations. We have numerically, algebraically, verbally, and graphically. Now numerically, that's usually values in a table. Algebraically, that's actually the equation expression written out. Verbally, that's going to be a sentence format of what is found algebraically or numerically. And then graphically, we have some kind of a graph representation of the data in a table. So if we look here, we have an example of all four. So numerically, we have this table here on the left, and it's gallons of gasoline, and the price in dollars is how much it's going to be. So for 0 gallons, it's $0. 1 gallon is $2.95, and 5 gallons, $14.75, and so on until we get to 20 gallons is $59. So that's numerically. Now graphically, we have this nice graph of it's linear. It's going up, changing as over, a number of gallons, the cost goes up, and it's in a linear fashion. And algebraically, this equation of the line is y equals 2.95 times x, which is how we get this is from here. We have 1 gallon is $2.95. And so if we put in 2 gallons, what is that going to be? Or what is it going to be if we put in 10 gallons or 20 gallons? We're just going to take that 2.95 times the number of gallons, and that will give us the number of dollars we have to pay. And verbally, the price at the pump for gasoline is $2.95 per gallon times the number of gallons pumped. And so we see all four representations here. Now, what is a function? Well, it's a rule that assigns exactly one output to each distinct input. So the input is usually labeled as x, while the output can either be labeled as y or f of x. And the more common one is f of x, but sometimes y is used just for simplicity. Now, in the gasoline example, the gallons of gas pumped in is the input, and the price paid is the output. So when an input is, say, 5 gallons, x is 5, the output, f of 5, is equal to 1475, because remember, our equation was y equals 2.95 times x, or if we wanted to, we could put it as f of x equals 2.95x. So when x is 5, then we have our f of 5 equals 14.75. Now note it's important to specify the units of measure for both the input and the output of the function. So in the gasoline example, the input is gallons of gasoline, whereas the output is going to be in dollars. Now the price of gasoline was in dollars per gallon, so that's kind of a key thing too. And our graphs should include units for interpretation. So if we go back here, we've got the cost in dollars, we've got the number of gallons, and so that makes sense. Our table, we had gallons of gasoline, dollars as the price, and so, we have everything here as well as in verbally. Now, the algebraically, you're not going to have any of the units because you're just going to have an equation. Now with a given function, we can find and interpret both model input and output. Okay, so when calculating the output, we basically are just going to substitute the input values into the function and simplify. So, before when we had f of 5 was 2.95 times 5. We plugged in the 5 for x because that's what it said to do, and then we simplified. So that's all we have to do is take 2.95 times our 5, and we get our simplified output. Now, when calculating the input from a given output, what we have to do is we have to substitute the given output into the function and then solve for the input variable. So in that case, maybe we had 59 was equal to 2.95x. And so we had to solve for x, so we had to divide by 2.95, and then we could get x is equal to, and I think that was supposed to be 20, but let me check for sure. Yeah, that's 20. And that was going to be gallons. Okay. And so it works both ways. Sometimes you plug it in and simplify this way. Sometimes you plug it in over here and then solve for the x. So that's what we're going to do. We're going to practice this. So here it says calculate the output values that corresponds to each of the input values of the function. Round your answers to 3 decimal places when appropriate. Okay. So we have a function s of t is equal to 3.2 times t plus 6. And we want t equals 5 and t equals 10. So S of 5 is equal to 3.2 times 5 plus 6. And so we'll take 3.2 times 5 plus 6, and we'll get our value. And so if we take 3.2 times 5 plus 6, we should get 22. And if you want to do this on a calculator, what we would have, let's clear all this, we would take the 3.2 times the 5 plus the 6, and we get 22. Now, our other question said to do 10. And so we would take then 3.2 times 10 plus 6, and we get 38. Okay, so let's go back here. And so we could say S of 10 is equal to 3.2 times 10 plus 6, and we said that was 38. Okay. Now we didn't have to round to any decimal places because they were just nice whole numbers, so we were good there. Now this one, it looks like it might have some bigger decimals, and so we're going to plug in n is 3 and n is 0.2. So we're going to have t of 3 equals 15e to the 0.5 times 3, and then minus 5, and then it's going to be n is going to be 3 squared. Okay, so this is going to be a little bit more tricky plugging into our calculator. So let me write this down: 15e to the 0.5 times 3 minus 5 times 3 squared. And then the other one is going to be times 0.2. So we'll get that. And so let's go to our calculator. And so let's clear that. And so we had 15 times e. And here's e. So we're going to have a second ln, and it was the 0.5 times 3, and then we need to arrow down so we can get back down to here, and then subtract off from that 5 times 3 squared. So in theory, it should be 22.225, 22.2253. That 3 won't round up, and so it'll be just 0.225. Now we can cheat, and we can say, well, let's do second enter, and we're going to, instead of the 3, we now want to do the 0.2. So we put 0.2, and then we can arrow down, and then we can hit enter, and we get a negative 28.422, and then that's a 4, and so that's not going to round up, and so we just have the negative 28.422. So let's go back and write that down. So this one we said was 22.2253, and so that's approximately the 22.225. And then we had t of 0.2. Oops, that's not going to be the right answer because I forgot to change that one. So let's go back over there. I just realized that. Let's go. And so this is going to be 0.2 now to the second instead. So now that should give us a correct answer. We have 0.2 here, 0.2 here. All right, so it's actually going to be 16.37756. And so let's write that down. Good thing I noticed that writing it here. And so we get that was 16.37. And then this extra 7 was going to go, was 5. And so that's going to give us 16.378. Okay, and so those would be our two answers on that one. And again, these didn't have decimals, so we didn't have to worry about it. These did, so we had to round it up to the 3 decimal places. And again, all we did was we plugged in our values for n here and our values for t up here. Now what about this one? It says solve for the input that corresponds to each of the given output values. Again, round to 3 decimal places. All right, well here we have t of x is 10 and t of x equals 15. Well, what we're going to do is we're going to say, well, that's 10 equals 5x squared minus 3x plus 2. Now what we have to do is we have to solve. And so looks like we're going to have to get that 10 to the other side. And so we get 5x squared minus 3x minus 8 equals 0. And now with this, what we're going to do is I'm going to use the quadratic formula because I'm not going to try to factor this even. I'm just going to say, okay, well, let's just use quadratic formula. And so it's going to be a minus b, which is a minus 3, plus or minus the square root of b squared, so minus 3 squared minus 4 times a, which is 5, times c, which is negative 8, all over 2 times a, which is 5. Okay. And so then if I simplify that, let me write that down so I can plug it into the calculator. And so it's going to be basically 3 plus or minus the square root of 9 and then plus, and that's 20 times 8 is 160 all over 10. And so now we can plug that into the calculator. And so let's clear that. And so we have 3 plus, and then we're going to have the square root of 169. And then that's going to be the numerator. And let's go ahead and put this in parentheses so we can have the whole numerator. Parentheses are very important on calculators, otherwise you don't get everything. And then divided by 2 times the 5, which was our 10. And so that gives us 1.6. Now we also need the negative of it. Oops, we should put a minus there. And we get a negative 1. So we get 1.6 and negative 1. All right, so let's go back over here. So we get two answers. We get 1.6 and negative 1. So we get two values, okay? And we expect two values because it's a quadratic, and so we're going to expect plugging in two different values, we're going to get the same thing there. So those are two x's. So x equals 1.6 and x equals negative 1. All right, well, what about the 15? Well, if we plug in 15, we do the same thing. We'll subtract 15, and we get 5x squared minus 3x, and then 2 from that's minus 13 equals 0. And so we're going to get the same thing, a minus 3, plus or minus the square root of negative 3 squared minus 4 times 5 times negative 13 all over 2 times 5. All right, so on this one, we'll have 3 plus or minus the square root of 9 minus 20 times 13, so 260, that's going to be plus 260, sorry, all over the 10. So let's go plug that in our calculator. So we're going to have parenthesis 3 plus square root, and then we had the 269, and then in parentheses divided by 10. And so that gave us, now this one gives us a couple more, so 1.940, and that 1 doesn't round up, so it'll be 1.940. And then we can do also the negative, put minus here, and we get a negative 1.340. Okay, so we get two values. And so here we get 1.940 and negative 1.340. So x equals 1.940 and x equals negative 1.340. So we get two values for both of these, which is to be expected due to the fact we have the quadratic. All right. Let's do another one. And this one I'll do one way, and then I'll do on the first one, and then I'll do it a second way to kind of show you how your calculator can help. So on this one, we have, let's do this one here. We'll do 9.4 equals 2 ln 1.8 times 1.8, and that's to the x, okay? And so we know we have to get rid of everything and get just this by itself. So we're going to divide both sides by 2 ln of 1.8. Okay, so on this side over here, those are going to cancel. So maybe we should show that. So that will cancel that. And so now this simplifies into 9.4 over 2 ln of 1.8 equals 1.8 to the x. Now, what do we remember about our algebra to get rid of that? Well, if we take the ln of this, this then can come down front. But if we take the ln of that, we also have to take the ln of this. And so then that tells we have ln of 9.4 over 2 ln, oops, 1.8, we'll put it in parentheses, that's fine, equals x, and then that's times ln of 1.8. Okay, now we've got x, but we have this other thing over here, so let's divide by ln of 1.8. So we'll divide all that by ln of 1.8. So again, all of that's going to cancel. And so we're going to get x is equal to, now we have to type all of this into our calculator. So we're going to have the ln of 9.4 divided by 2 ln of 1.8, and then divided that by ln of 1.8. And so hopefully I can type all that into the calculator. All right, let's clear that. And so now we're going to take ln, and we'll have 9.4, that's in the numerator, divided by, and then 2 ln of 1.8 in the denominator. So we have that closed, we have that closed, and that closed, and so we have one more, divided by, and then we divided that by the ln of 1.8, and we end up with 3.5369. Okay, and that's going to be our first solution. So let's go ahead and write that down. 3.5369, and if we do it to just the 3 decimal places, x is approximately 3.537. Okay, and we get one solution. That's all we get. And so because of that, then I know if I want to solve this for 30, I would say 30 equals 2, and then I'd have ln 1.8, and if I put all that in parentheses, then I have 1.8 to the x. What I'm going to do now is show you a trick on a calculator. When you know there's just one solution, we can use this nice feature called go to math, and then arrow up because it's the last one, and we want to do this numeric solver. And so what we have something here already, so let's go ahead and do that. And we said 30 was on the left, and on the right, let's clear that out, we had 2 times the ln of 1.8, and then that was times 1.8 to the x, and then go down, and then in parentheses, and make sure that's what we had. And so then to get okay, what we have to hit is graph, because this screen over here is on top of this really. So we hit graph, and then we hit graph again to solve, and we get this solution. So we get 5.511 and then 25. Okay, so that's going to be our solution for when it was 30. And then so here x is equal to 5.5112, or x is approximately 5.511 if we do to 3 decimal places. All right. And so this is the algebraic way to do it. This is how we do it with a calculator. Okay. Much easier with a calculator and than it is this way. But the key issue is when you have a quadratic and you get 2 solutions, that solver doesn't work. It just gives you the positive, it doesn't give you the negative. And so unless you're really thinking, hey, there should be 2 solutions here, you might forget to do that second one, and then you'd miss that problem. So when you get it and you know there is only going to be for sure one solution, that solver works really well. All right, so here we got stock car racing. So the amount of motor oil used during the month by the local stock car racing team is G of T 100 gallons, where T is the number of months past March of a given year. And we want to write a sentence of interpretation for G of 3 equals 12.90. And then we want to write the function notation for the statement. In October, the local stock car racing team used 1,520 gallons of motor oil. All right, so for A, we want to write a sentence kind of like this last one. And so here, T is 3, and it's past March. So March, we have April, May, June. So we can say, in June, the local stock car racing team used, now we use 12.900 gallons. So if we take 100 times that, that moves a decimal 2 places, and so they use 1,290 gallons of motor oil. Okay, so that is going to be how we would do part A. Now part B, what we want to do is we want to go the other way. We want to start with a sentence and go to our function notation. So we're going to have G of something equals, now this one we multiplied by 100, so this one we'll have to divide by 100. So we're going to know it's going to equal to 15.20. And now October is what month after March. So we have March, and then we have April, May, June, July, August, September, October. So that should be G of 7 is equal to 15.20. Okay, and so that's going to be how you can work going both directions, starting with a sentence and getting something, or going from a function and getting the sentence. What about this one? Purchasing power. So it says a model giving the purchasing power of the 2001 constant dollar is, and it gives the function d of t equals negative 0.023 t plus $1, where t is the number of years since 2001, based on data between 2001 and 2010. Now, what was the value of a 2001 constant dollar in 2000 and in 2010? Well, what is 2000 from 2001? Well, that's going back a year. And so then we're going to have t is equal to a -1 because we're going backwards. All right. And so what we're going to find is d of a -1 equals, we'll have a negative 0.023 times a -1, and then plus 1.00. And so then if we keep going straight across, that's going to give us a 0.023 plus 1.00. So that's going to be 1.023. And if we put it into actual dollars, we don't have the extra one. It doesn't round up. And so that's approximately $1.02. Okay, so that's how much it would be then. Now, what is 2010 from there? Well, 2010 minus 2001 is going to be 9. So t equals 9. So we want d of 9. And so we have negative 0.023 times 9 plus 1.00. And so let's go plug that into our calculator. So we have negative 0.023 times 9 plus 1. And so let's get out of here. Let's clear that. And so we add a negative. Remember to use this negative when you mean negative something, 0.023 times 9, and then that was plus 1. And so 0.793. So this is 0.793, and if we round that up, it's 0.79. So basically 79 cents is going to be the value in 2010. All right, so what about B? Well, this is A. So B says, according to the model, when will the value of a 2001 constant dollar fall below 80 cents and below 75 cents? Well, 80 cents is going to be basically what D of T is. So we want to say 80 equals negative 0.023 T and then plus 1. And it's 80 cents, so it's 0.80, I should say, not 80. All right, so we have the, in terms of dollars and cents, and this is, go ahead and put that in terms of dollars and cents. So we want to solve for t here. So we subtract 1.00, subtract 1.00. And so a minus 1 plus 0.8, that's going to be a minus 0.20. And that's equal to a negative 0.023t. And so we're going to divide by 0.023. And so t is equal to what? Well, let's say we have that. So 0.2 divided by 0.023. And we get 8.69565. Now, that is going to be in years. So we're going to have, we'll have 8 years. So we need to write this down, 8 years. And so we need to subtract that off. So let's subtract off 8. And so that's going to be the number of months. So we have to multiply that by 12 to get that. It's going to be 8.34 months. 8 years and 8.34 months. Okay. So we have to go now back here and we say, okay, well, that was 8 years and 8.34 months. And what really would that be? Well, 8.34 months. 8 months is going to be August, and it's into 0.34 months, so that's going to be in September. And so 8 years past 2001, so it's going to be in 2009, and the 9th month will be in September. So September of 2009 is when that is going to be below 80 cents. Well, what about the 75 cents? Well, we do the same thing. So we'll subtract off $1. And that's going to be a negative 0.25 equals negative 0.023t. Divide by the negative. And so t is equal to, now it's going to be the 0.25 divided by the 0.023. Now remember, negative divided by negative is positive, so we don't have to worry about those signs. And so now let's say we have the 0.25 divided by the 0.023, 3. And what does that give us? 10 years. And so if we subtract off 10, and that many months out of a year, so we have to multiply that by 12. And so it's going to be 10.43 months. All right, so let's go back over here. So we know in 10 years after 2001, that's going to be 2011. So let's write that down. We have 10 years and then 10.43 months. So 10 years after that, that's going to be 2011. And 10 months is going to be October. And it's into the next month, so it's November. And so we'll say in November of 2011, it's going to be below 75 cents. Okay, sometime in that month. All right, so that's how I would do those two there. All right, I'm going to pause there and then I'll come back and we'll have a part 2 of this section.